Here in Wisconsin, we go down to the shore for a lot of reasons. Maybe you just need a little time to yourself to sort out a long work week. Or your 4-year-old just has to find that right rock down on the beach. For some of us, it's a chance to witness those far horizons that only a big lake can provide. It's a place where nature shows her true power, and at times it can be an awesome and destructive sight. And then a few hours later, it's back to a serene and placid beauty. This mysterious and contradictory place requires a delicate balance between human needs and the power of nature. But that balance can tip, as it did in Oliver, Wisconsin in 2002, where 3 families lost their home.
It was a nice house, but we had a trampoline and swing set and everything. Grandkids liked it. And we liked it. I had a 30-foot boat for Lake Superior, and this is a safe harbor for the lake, so and it's just the right distance from Superior so that it was warmer here than it is in town all the time. It's a lot cooler near the lake, so it's a good spot to work near the lake and then drive home and watch the tomatoes grow. Well, unless they bulldoze it down first. And that's what I guess they're going to do.
In August 2002, on the banks of the St. Louis River, 8 miles southwest of Lake Superior, a massive earth movement known as a slump occurred in the village of Oliver. This is a common form of erosion on slopes and bluffs, where earth debris becomes detached from the main slope and moves downhill in a single large mass. 3 homes were damaged, condemned, and later demolished. One of the homeowners, Ed Schley, was the first to notice the changes in his backyard.
It started last August. I went out in the garage, which used to be over there, and I stepped into the shop and went down 4 inches. And then it didn't stop. It just kept on going half inch a day. If it rained, a couple inches, and now I got a 20-foot ladder there, and that's not near long enough any longer. So it's still going. Every once in a while, the river turns red, and soil from underneath the ground just heads on out into the river, and she settles some more.
Geologist Jack Zengel has been studying the Oliver site for the last year and a half.
Well, here we are in Oliver, Wisconsin, and we're standing on a large earth movement, earth failure, something that geologists refer to as a slump. Very, very common. In fact, we can drive from Superior to this location here in Oliver, and we would have passed maybe 5, 10, 15 or more slumps right on the roadside. So they're not unusual features at all. The unusual factor is that it occurred so rapidly, right in the middle of a populated coastal area of the region, and that the feature is so darn large. When you walk across the slump itself, it's about a football field in size. I guess the other major point to reemphasize again is that, this is Mother Nature at work. Mother Nature's goal is to move earth materials from unstable positions to more stable positions. The problem that enters this whole scenario is when humans live in areas where they don't perceive or recognize that there's the potential for such an earth process to occur underneath their home. So that's a very, very big problem.
As Professor Zengel said, several factors came together to make the Oliver event a dramatic example of shoreline erosion. But in fact, the causes and conditions that brought it about are very common. One of the major elements that led to the slump in Oliver is a layer of red clay, shown here in the original 1851 Geologic Survey map. This layer of glacial till was created around 11,000 years ago during the retreat of the last glaciers. During this time, glacial Lake Duluth covered large areas of the present coastline. But Lake Superior's history is much older than that.
Well, the Superior Basin has been a basin for a long time. Actually, it's geologically been a basin for a billion years, or over a billion years. At that time, there were two continents that actually started to pull apart and form a trench in the Lake Superior area, similar to parts of the Middle East today. And in fact, Lake Superior was left as what's called a rift valley. Probably had a lake in it at that time that was similar to the lakes that we have in North Africa today. Very deep, long, narrow lakes. For a long period of time, erosion has taken place. So much of that basin has been eroded by streams and then most recently by glaciers. And for the last 2 million years, glaciers have been coming through the Lake Superior Basin, further carving out the basin and making a depression. So when the glaciers retreated for the last time out of here about 10,000 years ago, they left behind this deep lake, which of course since then has had waves develop on it, and the shoreline has been eroding. And the shoreline has probably gone back on the order of, well, certainly miles, maybe a half a dozen miles, maybe in places 10 miles since the time the glaciers were here.
In recent years, Professor Michelson and several University of Wisconsin geology students have integrated years of field measurements with a computer model and have developed a program for predicting shoreline bluff instability.
So if we know the strength of the materials, the strength of the clay that's in the bluff, and we can measure that in the laboratory, and then if we know the angle of the slope and the height of the slope, we can basically calculate what's called our factor of safety. And that would determine whether the slope is likely to fail or whether it will be stable and stay where it is.
Even this sophisticated computer model cannot predict shoreline erosion with 100% accuracy. There are dozens of factors that affect exactly how the shoreline will change at a specific location. Sorting them all out and understanding how they interact can be complex and confusing. Professor Michelson is going to take us on a short walk down the beach and interpret some of these factors for us.
If the lake were permanently lowered, these slopes would become stable and vegetated, and they'd be like any normal slope that you'd see in the woods in Wisconsin. But here, the beach plays a very important role because it's the buffer. It's where much of the energy of the waves is released before it can get to the bottom of the bluff. So if lake level is low, then all of the wave energy is expended on the beach and the bluffs are reasonably stable. But when water level is fairly high, or when the beach is very narrow, then waves can cut into the base of the bluff and destabilize the bluffs, and that creates problems if there are structures, houses, and so on that are at the top of the bluff. If development were to take place on a cliff this high, it would have to be set well back from the edge, because even if all of the wave erosion were stopped immediately, these slopes wouldn't be stable in this position. But in fact, they would go back to quite a bit more gentle slope before they were actually stable. So even if the shoreline is protected on a high cliff like this that's fairly steep, there's going to be a substantial amount of bluff top retreat. Recession rates have been measured by looking at old maps and also looking at aerial photographs taken at different times in the past. And the recession rates along the Lake Superior shoreline are typically on the order of an average of a foot a year, 2 feet a year. There are a few places where it's up to 5 feet a year, particularly where there's been some human modification of the waves so that their energy is focused in particular places. With relatively large trees on the slope, it might give the impression that that's a stable slope, but in fact, over the long term, it's probably not stable, and those trees are slowly moving down slope. It's a process called creep, and on these clay soils, creep takes place at very low slopes, slopes less than 10 degrees. It's not dramatic, but it's something that people who are interested in buying lakeshore property should be aware that this is a very dynamic environment, and even though you see mature trees, it doesn't mean the slope is stable for a long period of time. Oftentimes in the fall in Wisconsin, on the Great Lake shorelines, the waves are larger than the waves that come in summer, and so the sand on the beach is eroded away and carried out offshore. In some places, the beach gets entirely taken away, and then large storm waves, particularly in November, before this fairly solid ice along the shoreline, do a great deal of damage in a short period of time at the base of the bluff, and preparing the way for the bluffs to fail next spring when there's lots of snowmelt and rainfall. I think it's common for people who come up here only in the summertime to not recognize that there can be big waves on this lake that can actually move lots of material. It might take away 8 or 10 feet of this bluff in one single storm. And in the summertime, we typically don't get waves that size, so it's not, people aren't always aware of the possibilities that might happen when they consider buying property along these bluff shorelines.
Those were the factors visible on our short walk, but the list goes on, and every stretch of shoreline offers its own unique mix. So how can we sort all of this out? What can we do about it? Luckily, while the questions are complex, the answers are relatively simple, and they have more to do with people than with shorelines. So let's turn to Professor Michelson one more time and see what he has to say based on his long experience with the Great Lakes.
Well, people often ask, what's the solution to shoreline erosion problems? And the solution really depends on what the problem is and who's seeking the solution. Individual homeowners would like to live close to the edge of the bluff so they have a good view, but on the other hand, it means that the life of their structure is going to be limited, and maybe it'll be 10 years, 20 years, 30 years, but people have to recognize that this erosion process is a natural process that goes on all the time. Now, there's some places where structures can be built. This is for instance, sheet piling that's been put in to form a harbor, but that isn't typically practical for the individual homeowner. And we have to be a little careful as we see more and more development on Wisconsin shorelines that we don't completely armor the shoreline and cut off the supply of sand to its beaches. Individuals buying property and building should probably recognize that they should stay away from the edge, build it far back as possible, and have a building that'll be there for their children and children's children, and not be dropping into the lake in their lifetime.
Stay away from the edge. If we had to distill all of this down to one solution, that would probably be it. But in the real world, we don't always do the ideal thing, or always know what it is. The people of Oliver faced these challenges, and the story of how they dealt with them will help us understand what can occur when we stray from best management practices.
Well, we tried to, at first find out if we could get some answers from somebody as to what was happening, why it was happening, and is there something we could be done about it to prevent it. And the engineers and the experts from the state that deal with this kind of stuff, they were of the opinion that there isn't enough money to fix this problem that's here. Not that maybe it couldn't be fixed, but there just isn't enough money. FEMA from the federal provides 75% of the funds. Then the state of Wisconsin provides 12.5%, and the village provides 12.5%. It all comes from the taxpayer, just, which pocket does it come out of? The reason there was funding available was was because a couple of years ago they had some tornadoes not too far south from here. And because of their misfortune down there happened to be some funding left that could be used here for these people's misfortune. And right now, I don't think you could get any funding from anybody for something like this. So these people that are here, they're very fortunate because the property basically right now is not worth anything. There was only so much money that was available, and the agencies that disperse this money, they tell you how far they're going to let you go, which is probably a good thing because you could run a $450,000 project into probably a million or two, without any trouble along here if you were going to try and buy everything out. Well, most of these houses have been here forever. There was probably not any real restrictions anywhere in the county when these houses were built. And I don't think anybody ever really thought about it much, give it any thought, that something like this was going to happen. If I would have been able to purchase a piece of property here and build a house, I probably would have purchased it and built a house and not thought about it. Now seeing what has happened here and being real aware of it, I think that some things should be changed. There should be restrictions on how close you can build to the edge of this hill. Yeah, and people don't like restrictions. They don't like anybody telling you what you're going to do with your property, and I'm just like the rest, but you have to have some rules. And the taxpayers can't keep buying property out. It's quite a costly process.
As Don Kersak said, it was very unusual that funds were even available for the village of Oliver. Due to public safety factors, Wisconsin Emergency Management was called in to coordinate the crisis. Federal, state, and local governments all worked together to solve the problem. A hazard mitigation grant was obtained and the houses demolished. Now, these properties are deed restricted and no future development may occur on them. They must remain in the domain of the village. This story has been centered around 3 houses in a small village in northern Wisconsin. But the lessons learned apply to all of our shorelines, from Milwaukee beaches on Lake Michigan to the far western reaches of Lake Superior. What are these lessons? Are there a few simple rules we can apply to help us deal with our complex relationship with the Great Lakes? Luckily, the answer is yes. Gene Clark, coastal engineer from the University of Wisconsin Sea Grant Institute, has put together a short list of simple guidelines that can help us stay out of trouble and ensure that our shorelines are a safe and enjoyable place. Let's take a look. Think regionally, not individually. In other words, work together with your neighbors. Whatever you do to your property can affect others. And remember, we can never fully control nature. There will always be creep, slumps, and bluff-top retreats, because that's nature's way. But we can control human activity. While we can't stop Mother Nature, we can postpone her negative effects by building our structures further away from the edge, by moving structures that might fall into the lake, by maintaining natural vegetation instead of lawns whose root systems are shallow, by controlling groundwater and runoff with drainage systems, and by placing septic systems properly. Be sure to ask the experts about best management practices before you start any project. You can also learn a lot from publications and websites such as these. And last, understand the problem before reacting. Go slow and make sure you'll be making things better instead of worse. And always be prepared for the unexpected. Here in Wisconsin, we're learning how to live with our shorelines. Since the 1970s, the Wisconsin Coastal Management Program has been working with these partners to create a unified approach to nature's challenges. But everyone in Wisconsin who spends time on the shore can help. So please, enjoy and protect Wisconsin's Great Lakes.